Hello everyone and welcome to the first part of the project Trebuchet. Now what it is and what I aim to achieve. In this project I would like to design my own Trebuchet model that I would then 3D print, assemble, and if possible it would actually work, it would fire. Now as with other projects I would really love to use PLA as a material. Then I don't really think any paint would be necessary to be applied. I don't know yet, but I think so. And also, I would really love to design it in such a way that there would be no support material whatsoever, so that the assembly process is really intuitive, I guess would be the word, or and no additional work would be required. Now, when it comes to the very process of designing the model, I didn't really use reference pictures like in other projects, but I use a reference video, particularly this one, how to make a medieval trebuchet from Numavik. The link would be in description, and the video is really great. I really like how he showed how to make it, and I kinda stuck to this design, though I changed it a little bit. Made I made few changes here and there. Though what I really used from this video is actually this diagram with dimensions that I tried to basically uh, copy and use in my own design, because there is a strong importance between this overall dimension 354 and the dimension of the distance of the counterweight. So that's basically what I needed and what I took as my starting point. So now we can go to Creo and take a look at the final design. So we are here in Creo and this is the trebuchet model I have so far. Now as you can see, it looks a little bit like the design from the video, though I hope you can see that there are some changes. Um, so I will try now to explain what I did and how I did it. So as you can see, the model itself consists of several pieces that are put together with this approach. One has a hole, other has holes, and those two snaps together. Now, because the material is PLA, I try to make basically no allowance between those two parts that would be connected together and snap them, well, forcefully, so that they are tightly locked, and that way I hope I will avoid using of any glue, or not any glue because there has to be glue, but that it would minimize the amount of glue that is actually needed. Now, as you can see, for example, here in this part, I have it divided into two. Here I basically has no other way around but to use glue. Why I was forced to do that? It's simple. With my initial design, I didn't really consider the printing bed of the printer, and the maximum dimensions that it could print is basically 20 to 20 centimeters. Thus, I had to take a look at those designs I have and those that are larger, longer, or wider. I simply had to divide into. The same goes for those two side pieces. As you can see, they were one piece, now they are two. What I did here is that I prepared those little slots, and into them I inserted these locks, I guess we could call it. Sure. Now, after the design is complete, I can say that this wasn't the best design because I could make some locks uh, straight from the one half to another one, but well, live and learn, I guess. So now the idea is that I will put those two halves together, insert those locks, and basically that would centralize it, and I could apply some glue and glue everything together. Now when it comes to here, to the shaft, it's basically designed in such a way that I have a big hole here. Into it I put that and that insert, and inside that insert we have this long shaft, and on the other side we have this, well, washer. And the idea is that there is no allowance between the washer and the shaft, so they are tightly locked, and that could all hold this entire piece together. The same goes here for the counterweight. It's the basically the exactly the same design. Yeah, those two washers are the same. Now, as you can see, here is some model of the rope or the string, I guess. And here we have a string that goes through the entire arm, and here we have assembly of basically mechanism that could be pulled. Now, yeah, you can see that I didn't really bothered with the proper shape of the string. That's because I had a different design originally, and then I changed it, and to actually add this part, so that the rope is or the string is held basically parallel to the side walls. And then I was, yeah, I admit, a little bit lazy to actually change the shape of the rope, but I don't really think it's that necessary because after all, rope is something I wouldn't 3D print, right? Anyway, the idea is simple. Here we have a shaft with the string attached to it, and here we have a pair of pulleys on the other side, and they will lead the string here to the other pair, and from that it will go straight to the shaft. And when you actually rotate it, it will pull everything up. I obviously didn't really animated the movement of the rope because why would I? And here we have this assembly. It basically has this pin that ties everything together. It has those two um, wheels, and it drives on the string on it. When I put the pin out, the entire assembly disconnect and I can fire basically. Then I will attach it once again and I can pull it down. Here we have a firing mechanism. It simply lock this um, this part in place. Then I will pull it down like that, and the entire thing fires. Now here we have a slider. Here the sling will rest with the projectile and then shoot. The slider is also made using glue because, as I said, I really like to avoid having support material, and here I had no choice because here I have those three pins. Thus I had to divide this part into two. The one would be printed with those pins, one with this slider, and then I will glue it together. And the idea is to then snap it into those three openings, Thus, it would also straighten it and hold it together. Now the counterweight assembly is basically like Lego. I have two sides with various pins here and there, and those parts with the holes, so it will all snap together just like Lego. So that would be probably all when it comes to the design itself. In the next video we will actually take a look at the printed material and assembled together. We will basically take a look at the model itself. So for now, I can only say have a very nice day, and until next time, bye bye.